part 3, and this is a part of SAT Calculus. So let's start with a few problems. We will also be introducing definite integrals here. So let's start with problem 1. Evaluate integral arc tan x dx. So let's come to the solution. Arc tan x is nothing but tan inverse x. So this is tan inverse x. We are going to integrate by parts. So take the second function as 1. So tan inverse x into 1 dx. So that will be u integral v tan inverse x integral dx minus integral of derivative of tan inverse x is 1 by 1 plus x squared. Integral of dx is x dx. So this becomes integral of dx is x. So you get x tan inverse x minus, make a substitution here. You will put 1 plus x squared as t. So 2x dx equal to dt, or x dx equal to dt by 2. So this becomes minus integral dt by 2t. So that would be x tan inverse x minus half. Integral dt by t is log mod t plus c. And now you need to substitute back. Whenever you make a substitution, substitute back. So you get x tan inverse x minus half log mod of, instead of x, I will put 1 plus x squared plus c. So this is your solution. Okay, coming to the next question, that is evaluate integral e raised to 2 log u du. So this would be, the solution would be, this would be integral e raised to log u the whole squared to the base e du, because integral, we have a log m is log m raised to a. And the base is the same, so this will be integral of u squared du, which would be u cubed by 3. So that is your answer here. Let's move to the next question. Evaluate integral tan theta minus 1 the whole squared d theta. So this would be integral of a minus b the whole squared. Tan squared theta minus plus 2 tan theta minus 1 d theta. Now 1 plus tan squared theta, sorry, it would be plus 1 and minus 2 tan theta, a minus b the whole squared is a squared minus 2ab plus b squared. Now 1 plus tan squared theta is secant squared theta, so it becomes secant squared theta minus 2 tan theta d theta. Integral of secant squared theta is tan theta, so it is tan theta minus 2. Integral of tan theta is log mod sec theta plus c. So this will be your solution. Let's going to the next question. That would be evaluate integral d theta by 1 plus sine theta. So let's start with the solution. We rationalize, so you multiply and divide by 1 minus sine theta, and the denominator becomes 1 plus sine theta into 1 minus sine theta, which is 1 minus sine squared theta d theta. So this becomes integral 1 minus sine theta. What is 1 minus sine squared theta? Cos squared theta d theta. So splitting the integrals, you get integral 1 by cos squared theta minus sine theta by cos squared theta d theta. What is integral 1 by cos squared theta? You get secant squared theta minus, this will give you sec theta tan theta d theta, because sine by cos is tan. Integral of secant squared is tan theta. Integral of sec theta tan theta is sec theta plus c. So this is your solution here. Let's go to the next question. This is a word problem. Find the equation of the curve whose slope at xy is x squared minus 2 and which contains the point 1, minus 3. So let's start with the solution. So dy by dx is the slope of the tangent. This is x squared minus 2. So I get dy equal to x squared minus 2 dx, separating the variables. Integrating, you get y equal to x cubed by 3 minus 2x plus c. Now put x equal to 1. You are given that when x equal to 1, y is minus 3 because it passes through 1 minus 3. So substituting, we get minus 3 equal to 1 by 3 minus 2 plus c. So you get c as minus 4 by 3. So your equation would be y equal to x cubed by 3 minus 2x minus 4 by 3. Okay, let's move on to the next question, and that would be a particle. This is also a word problem. Moves along a line with acceleration 2 plus 60 at time t. When t equal to 0, its velocity equals 3 and it is at position s equal to 2. When t equal to 1, we have to find its position. So the solution goes something like this. A equal to dv by dt. So we have dv by dt equal to 2 plus 60, or dv equal to 2 plus 60 dt. Integrating, we get v equal to 2t plus 3t squared plus c, because integral t is t squared by 2. Now when t equal to 0, its velocity is 3. So when t equal to 0, v is 3. So 3 equal to c. So substituting here, we get v equal to 2t plus 3t squared plus 3. Now what is v? v is ds by dt. So ds by dt is 2t plus 3t squared plus 3. So ds will be 2t plus 3t squared plus 3 dt. What is this now? Variables separables. So integrating, we get s equal to t squared plus t cubed plus 3t. I'll call the constant as d here. Now you are given that when t equal to 0, it is at position s equal to 2. So at t equal to 0, s equal to 2. So substituting, you get s2 equal to d. And here, so your s becomes t squared plus t cubed plus 3t plus 2. Now what do we need to find? We need to find the position when t equal to 1. So put t equal to 1. So if I put t equal to 1, s becomes 1 plus 1 plus 3 plus 2, which is 6. So that is the answer. Okay, now that comes to the end of anti-differentiation. I will just introduce the fundamental theorem of calculus, and this is the basis of definite integrals, which we will do in the next session. So if derivative of f equal to f, small f, capital F will be equal to integral of f, and integral a to b of fx dx will be upper limit, that is f of b, minus lower limit, that is f of a. So this is a fundamental theorem of calculus. Now I will conclude with the mean value theorem for integrals. So the mean value theorem for integral says that if f is continuous on the closed interval AB, then there exists at least one element C, where C lies between A and B, such that integral a to b fx dx equal to f of c into b minus c. So that's the mean value theorem. So that concludes this lesson. So this is basically anti-differentiation part 3 for AP Calculus SAT Maths. Thank you and stay tuned.